I know, like, dang. Granted, the way you and Peter go at each other, is it a stray or is it just a continuation of the normal?
What if I just jump out the window? Like, what then?
Notice how no one cared?
Oh.
Dang.
I care if you jumped out the window.
I don't.
I literally had the clicker earlier. Does anyone see the clicker?
Dude, you always, I see it.
I see it. It's right there in those napkins.
Oh, see, that one wasn't my fault. Miss Kolsky was trying to hide it from me.
What? I didn't use it.
No, you put the paper towels on top of it.
My bad.
Dude, he uses
All
that
right.
every single day.
So, number one here, and this
You said lights
was... No, I refuse. So this was the first on the progress check A.
I don't know. I just said something.
Alright. So a health professional, you'd be in the Jax. That's the only one that doesn't have to read.
She just never wants to sit with us.
So a health professional is investigating whether stress level before a routine practice session can be used to predict the mean stress level before a major figure skating competition.
Wait, this is not
The health professional selected a random sample of 6 figure skaters and measured the stress level before a routine practice session and before a major
Is this
competition.
unit 9 or unit?
This is unit 9.
Okay.
Each variable was measured as the change in the interval between heartbeats or heart rate variability. Health professional wants to estimate the mean change in the stress level before a major competition for each unit increase in the stress level before a routine practice. So which procedure should we use? A was the most commonly chosen answer. What do we think?
I thought you matched the
I thought
figure
Ron, you
skaters
did
before and
not.
after.
No. I
So
say it's E.
Yeah.
saying E.
Yeah.
I don't even know what
I mean,
you're
yeah, 'cause
saying.
it says something along the lines of
We're also on
the
unit
change.
9, so like.
It says like for each something.
Yeah,
Yeah,
that's
each,
what I thought.
yeah, each
So-
unit increase. Yeah.
And it does have means in here, but that would be the change in Y hat to the change in X because it's 1 unit increase.
I know some of y'all got this wrong too. Don't
I literally said this was the most selected answers.
Exactly.
You know? So,
They'll act like
matched pairs make sense for some of us because, hey, that data is paired together. It's paired on one person. But notice, is it 1 variable or is it 2 variables? 2. And guys, so hear me on this. Once again, I need you to hear me clearly. The matched pair stuff was always how many variables?
2.
One.
It was 1. It might have been,
Together.
yeah, it's paired on the same variable, right? So the fact that we have 2 different variables forces us into a linear, right? It's a linear regression T.
I just guessed E because that's the unit we're
That
on.
makes
Thank you.
That's what I'm
Here's
saying.
like
That's
100%. Okay, good. Now at the same time,
But this is a,
on the actual AP exam, you can't pull that logic, right?
Sure.
We have to recognize on the actual AP exam, hey, which that's one thing I don't like about the progress checks, is like, oh, I'm only on this one unit, only could be a question about this. But it is important to recognize, hey, there's 2 different variables. So it's got to be a linear regression, okay? So a linear interval. All right, so right here, similar thing. So this is, again, a commonly missed question, but it's the same idea. Notice the audience score, or what is, yeah, the audience score is dependent upon the what? Critic review, or critic rating. The critic rating is predicting the audience score. Do we have 1 variable or 2 variables? 2. Notice we have a matched pairs answer right here. But if it's 2 different variables, it's got to be a linear regression. It is paired on that 1 data point, but it's a linear regression because it's 2 different variables. All right, I'll go ahead and tell you this. For all those who missed this question, I do not like this question. Okay?
Yeah, that's kinda trash.
This
Oh,
is-
yeah, that's
This is a
kinda
trash
Honestly,
question,
it makes
okay?
me feel.
Because here's
Yeah,
the
it's
thing.
only here,
The actual answer is A.
Yeah.
But
Well, that's not an addition then.
right, the reality is, are X and Y nonlinear?
Right.
Yeah.
Yeah, right? The relationship between them is nonlinear. That's why it's got this curve on the residual plot. But do we want them to be nonlinear?
no.
No. The reality I will say is I would have thought 2 if it had to be one of these, but you cannot determine if observations are independent on a residual plot. That's not going to tell us that, okay? You got it, Chris? And does the standard deviation of Y not vary with X? Well, I've got really big standard deviations here, or the deviations here, small deviations here. So the standard deviation is not consistent all the way through. So it's not 3. So, terrible question. This one, though, we cannot miss. This is literally asking us to what? Interpret a confidence interval. D and D were our most common. 98% confident that predicted starting salaries will be between this and this. But what is a confidence interval doing? Capturing a parameter, right? Like we cannot forget, a confidence interval is capturing a parameter, and this is a confidence interval for the slope. Is there any language here about capturing the population slope? Down here, we are 98% confident that the regression equation can be used to make accurate predictions for placement scores between there and there. Again, do we have a slope? No. What is the only answer here that is interpreting a slope? You said C?
Yeah, C. Yeah, it is.
That is the
Yeah.
answer?
Yeah,
So we are 98% confident that a 10-point
Yeah, C
increase
is the correct
oh,
answer.
will result in
Don't-
predicted
don't
increase.
doubt me.
My bad, my bad.
Don't doubt me so much.
That's all.
Because, yes, 10 points, so that'd be the 315 and 336, yes. Okay, so I will say this predicted increase is the idea of the slope, right? That's why it might have thrown me off, or thrown us off for those who didn't see it, but a predicted increase, an average increase is the idea of the slope. Notice it could not have been A, because what is it talking about right there? Probability, right? Alrighty, woo! I did not expect, so this is actually moving away from the Unit 9, this is moving into the Unit 2 progress check. I did not expect us to have a problem with this. The most common answer on
Wait, let me switch to
What question?
Wait, what? What's
which,
going on?
wait, is it
Yeah,
2A or 2B?
2A,
so.
question 9 maybe or something, I don't know.
It's not.
Oh,
wait,
what's
wait,
it about?
It's not 9.
Wait,
Chameleon then?
It's 10, it's 10.
Yeah.
I was
chameleon,
close,
yeah.
10. So this is 2A, number 10.
Oh,
Everybody but one person missed this one.
That might have been.
So how can it be, like, how can there be an association but it not be lineal?
I mean, as age increases, does it give me some prediction in the mass?
Yes.
So if there's a correlation, if there's some kind of prediction, even if it's nonlinear, it's still an association.
Okay.
Okay?
Okay.
Okay, so what did most of us put?
Positive linear.
B.
Most of us put positive and linear. Very clearly, it's not negative, right? Like as we go to the right, the mass goes up. That's a positive relationship. I don't like that they have that language for a nonlinear relationship, but it is nonlinear. Like if I draw a trend line right here,
because it's like curved. It's like a log.
That's just because
It's
it's
a
not
log,
very
log.
good.
function.
So I was looking at that, but I was like, he's gonna say that I was dumb if I picked
Okay,
that.
but like it's kind of.
No saying.
No, because I thought that if I clicked non-linear, you were gonna get onto me and be like, dude, it's
No.
linear. Look at the
now
line.
it's not linear though.
See, now he's
I'm never right. I'm
traumatized.
never right.
Now he's
Listen, I will say
traumatized.
this. Listen,
It does
if you
look
take
linear.
out those 4 data points, I would agree.
Bruh.
You take out those 4, then it's a linear relationship through here. You see how it's very scattered around there, right? But you with these data points, now at the beginning I've got some below, at the end I've got some below, but then the majority are above.
It's like a log graph.
Yeah. So like it is much more closely like that. That would be a better prediction model. A line would not do a great job here.
So did most people choose B?
Most people chose B, but the answer is D.
I just remember some of that FRQ.
That one was
He's traumatized.
clearly linear.
He's traumatized.
That free response question on the mock was
I was
definitely.
like,
Maybe
there's
you
a
should
4
show
points,
us
but I
about
thought
it.
you were gonna say that's not enough to like make it non-linear.
No, it is.
Say.
And I will say this: it's goofy, but even a single data point can make it, if it's in the right spot, make it look nonlinear if it creates some kind of curve. In fact, there was, and I'll probably pull it out. There was an exam 10 plus years ago, I think, where they did that, and I hated the question, but the relationship was nonlinear. It does happen, but it's been once.
So how many of the exams have you done?
How many have I scored?
Like, have you just done? Because you said you remember all these questions.
I mean, over the years, I've done a lot of them. it's not like I just sit there and do it after the AP exam unless I taught the class that year. And when I teach the class, I go through and I do the free response as soon as they release. But I mean, like, think about how many free response questions I've had y'all do this year. I've done all of those or more. It's like I've never asked y'all to do anything I have not.
How nice.
Yeah, alright, so scatter plot below displays the relationship between, this is a later question of the same progress check, between the percent change in the population of wolves and the moose density in number of moose per square kilometer over a 19-year period in a certain region.
Which question is this?
I know what it is.
Oh, I see it. Oh.
Okay, what number is it?
11, I think.
Okay.
12.
Wait,
12. Notice that the association is negative and that the points seem to be more spread out at higher moose densities. Suppose the variables on the scatter plot were reversed so
This
that
was so
moose
confusing.
density was the response on the vertical axis and percent change of wolf population was the explanatory on the horizontal axis. Which of the following would be true? Well, here's what I want you to think about, right? Because I totally get it. And this would have taken me a while as well. But my understanding, so let's do it this way. My understanding of inverse functions makes this one make a lot more sense. What is an inverse function?
Oh,
Like the X is your Y and Y is your X.
So the inputs and outputs
Are flipped.
are flipped. The mathematical term that some of you may have heard is transposed. But that is essentially where they're
like
switched.
constants?
Okay? Now, graphically, do you know what happens when the X and Y axes are flipped when they transpose like that?
Right, no,
Stays
obviously
the same.
not.
Yeah, it stays the same.
What do you mean?
Like
I
if
don't
they
know,
just switch, then it's.
You're just rotating it. I mean, the
You-
correlation would stay the same.
I mean, like you just have to visualize it. Yeah, it's still going.
Yeah, just visualize it. All the
Yeah,
points.
I just said.
Because
Y
if you see the
X,
negative
X, Y.
25
Mhm.
right there, and then you kind of just like I just flipped it.
Graphically, it's a reflection across the line y equals x.
Sure.
That's like when X and Y axes are flipped, when we transpose those inputs and outputs, it is a reflection across the line y equals x. So all these data points will end up here, and all of these data points will end up down here. So what's going to happen?
Nothing changes.
Yeah, the association would still be negative, right? But the strength would not change. So that's a graphical way to see it. But I want y'all to also remember this. How do we calculate R?
Graph.
It's like changing Y over B times changing. Wait,
Oh, it's like the 1 over n minus.
So
Oh,
there's a
that
few
one.
different ways to calculate it. One is off the slope, but the better way that is the more technical is this.
Wait, so why is it n minus 1 for that one?
I'd have to go back and look to see why it's, well, but this isn't, notice this is not like standard deviation where we're estimating parameters. This is the correlation of those data points. I'd have to look at it. But I want you to think about it. It's just the product of the z-scores, right? If I switch the order of these, will that change anything? No, right? And that's what we need to recognize is the correlation coefficient, R, is calculated this way, like we're going to use the calculator to do it. But because of that, and this was again the idea of, if I change units, is that going to change R?
No.
No. If I switch my input and output, my independent and dependent variable, is that going to change R?
No.
I mean like the sign maybe.
Not even that.
Oh.
Because remember, these are still z-scores, right?
Oh.
They're still standardized scores, so it's not even going to change the sign. That's again why the association would still be
Same.
negative. What? Still be negative, but the strength would decrease.
What?
Oh, these answers are right.
E.
Huh?
The correct E.
E? Oh,
Yes.
the direction and strength
Yes,
would not
E.
change. Literally what I was saying, I just was not reading it right. Okay. Well, because I was looking for the association would still be negative. But yeah, the direction and strength would not change. All right. This one I want to look at with everybody because this is the last big one that I want to make sure we all understand how to do. There was one other one that was earlier, but it would not be on our exam or our test. It'll be on the AP exam. So a food truck owner recorded the temperature at noon in degrees Fahrenheit and the number of bowls of soup sold during the lunch hour for a random sample of 5 days. And we have our data here. What is the correlation between the temperature and the number sold? What do we need to do?
Put it in the calculator.
I would put this in the calculator. Could you do the 1 divided by n minus 1 times the sum of zx times zy? Sure, that's
Oh,
good.
yeah.
Okay, I need everybody to get a calculator out. I need you to do a list in spreadsheets and use that calculator to find your correlation.
Don't
I use my brain.
I ain't use my brain for that. That's what you
I didn't do all
Well, it
that.
looks like a negative, and then the correlation
I'm
seems
not
kind of
doing all
strong
that.
because it goes from
That's a
8
bold
to
jump.
12. So then I did negative 0.
Now, if you wanted to graph those data points and make that argument, sure, but don't just use your brain. Type it into a
Say
calculator.
Newton.
Don't make silly mistakes.
Yes, right.
Go sit down.
What's he doing?
He's being himself.
Oh, okay.
So unique.
What's wrong with that?
He is.
You're just hating on something.
Why is he speed running?
You should.
It's
Wait.
an Excel World Championship.
Yes, that's what I was thinking.
Try to make sure you have the data up there so that you can use it.
Bro.
that.
Oh, my ball's cracking.
Awesome sauce. You know, I didn't know I could.
Did you just say awesome sauce?
That's real.
Shut up,
Freeze the
Michael.
screen.
Why are you
No,
such a
I'm
hater?
literally leaving that up there and doing it this way
I was just
so that you can do
All I
it and
do
check your
is
answer.
live,
Guys, I
laugh,
need you
even
to
love.
go ahead
You
and
just hate me.
type this in.
That was more
It's a cringe to be joyful.
Correlation.
Any
So, if it's that calculations, what's going to be able to give us correlation? Yep, linear regression, that's fine. It'll still work. If you do A plus B, it's just traditional in stats to do A plus BX.
I don't.
And you found it. Yep.
Because I was staring at it this whole time, like, how am I supposed to get that?
Calculators, baby, let's go!
You sound
Calculators are my best friend.
Okay.
like you sounded like my sort of
I sound like what?
Doesn't interact.
Okay.
Honestly,
and I was right.
I hate it.
No, he literally said, "Oh yeah, let's get, baby, let's go." Did you not hear that?
You didn't label your list. You gotta type the list in. Guys, you gotta label your list. Alright, here's one thing I want to see about, so check your answers. You should have it. You should have one of those answers. Now, I know that it tells me a little bit lower exactly what R is, but how could I use this information right here and nothing else to figure out what R is? Okay, so take the square root of 0.725159.
Oh, that's 0.851560.
But there's a problem with that. What's the problem?
It's not negative.
It's not negative. You have to know whether it's supposed to be positive or negative. How do we know if it's positive or negative?
It's going
He's
down.
an old soup on
It's
holiday.
going down.
Because it's going down
Slow.
and the slope is
Negative.
negative. I want y'all to notice, right, like the sign of your correlation coefficient will be the same as the sign of your slope. I believe it even talks about that in the textbook if you read through and did your Ferrer models like I asked you to. Okay, it's like, what's a Ferrer model? Well, I'm not familiar with this concept, Mr. Kinney. What's a textbook?
What's a Potter?
What?
What's the?
Alright,
What?
so.
What's a green card?
Oh my god!
That is messed up.
Oh my god!
You know how hard to
You got neighbors right over there.
Cancel.
Moving past the blatant racism that I'll have to deal with later.
Turn your cancel.
Oh my god.
Oh my
That
god.
was the reverse was bad.
Call the camera.
No, it was her.
The dad, no, the dad.
Let's go. We got some chi-square stuff to look at. Make sure you are studying for your test, underclassmen, upperclassmen. You're welcome that you don't have to take it. However, it will be on your AP exam, so I'd still study that stuff. If you want me to at least give you a copy of the test,
Okay.
then you can get that to help you study for the AP exam. All right, I need you to get out the chi-square packet that I handed you yesterday.
Freaking packet.
Bring it Peggy, yeah.
How do I study for this test tomorrow? Because I'm scared. Can you reopen the progress checks?
I don't know.
He did. Serena. Ms. Kowalski, can you help me pass out the test?
Wait, what's the test on?
What would our FR keys be on? Is it gonna be?
Serena, I'm giving you so many FRQs.
What's linear regression?
Is it gonna be like doing a forcing method? It was a forcing method.
Wait.
Serena.
That is
I'm
never
gonna
on the
Serena.
AP exam.
Wait.
But what you saw on your mock, hey,
Serena.
what you saw on the mock exam is the most extreme that they have ever had.
Peter, I apologize. I'm sorry, and I will never do it again. And
I don't believe that. I don't believe that you'll never do it again.
Thank you.
Once you're racist, you're always racist.
Peter, I'll marry you so I can
Okay,
okay,
to be fair.
Peter said, "What is a dad?"
No, literally, like
Oh.
wait, it's a green card.
Y'all don't get it.
Y'all don't get it.
What's the joke?
The green card is still racist.
What's the joke?
It's what's the name?
That's what I thought.
Yeah.
It's what?
He's like, what's a
XXX Temptation.
Yeah.
Oh, now I get it.
Test on.
That's what I
Yes.
thought.
Test
You know
on-
that?
That's
why
linear regressions.
So you must not have a green card, Peter.
I do. That's the thing. That's the funniest thing.
You already took the test on.
I thought you said I was just gonna get you. I guess.
Bruh.
Dang.
Well,
Well,
I'm not crazy.
you're getting people
We
with
took the test
citizenship.
on inference with means, right?
What?
We took our test on. You're
I
trying
do not remember that.
What test?
Jaden's like, what about our test on means?
We
And I'm
didn't do
like,
that.
Huh?
We didn't do that. We haven't done that yet.
We haven't done
did
that.
do that.
No, we didn't.
I thought we was doing it yesterday.
Yeah, I thought we were gonna do it yesterday.
I feel like y'all
No, I swear to God, we-
are trying
No,
to
like on my
On my
on my dad.
We did it.
Well, that's not very trusting.
Yeah, what I think
All right,
about it.
everybody. So.
I was thinking,
remember it.
I didn't think so. I was
I don't know about
originally
that.
like, is there mean tests? I thought we were
they
doing
were.
Okay,
it
can you pass
yesterday.
out invitation?
Yeah, I'm ready.
Wait, I thought we were trolling. Did we actually not do a test?
No, I don't remember doing it.
I don't
I thought we
remember
were supposed to do
We
it.
did do a test.
How many?
Yes,
Oh my
we
God,
did
we're all gonna,
test.
I'm gonna
We
fail
didn't
because
do a
this
test.
game y'all playing.
We did do that.
We
We did do a test.
We did do a test.
We did do
How many do I give them? Mr. Rennie?
Huh?
Just an amount?
Yeah.
That's it. I'm gonna test me. That's not complete.
You were counting.
Because
I'm gonna give my favorite person the most.
models afterwards.
Yeah, I made the test up.
None of you.
Oh.
Yes.
Just kidding, guys. I don't know how many I'm giving you. I'm just kind of giving.
So you hate us all.
Yeah.
Wait, those are both for Lana?
What?
Oh, Lana is that.
Lana's sitting
Somebody
there.
take that one.
Nobody's sitting there.
I'm not thinking.
No,
No,
take Jane's baby.
it doesn't have.
Take it.
Take that.
Jane's baby self.
There's someone sitting right
right
here.
here. Should I take that one?
Yay.
Nobody's sitting there.
Oh, Lana's sitting over there, so you.
She's sitting right here. Right there.
Right there.
She's sitting over there. She always sits over there.
I don't even know.
You have M&M's. That's the most prettiest thing.
You're
I've ever
so
seen.
big.
He got M&M's in his hand.
sorry.
I'm like, can I get some? You make like my sibling or something.
Do people not get that at home? Wow.
No.
Well,
I'll
11
Serena gets that.
score in the grade book for a Unit 7 test on means. So, yes, you took a test.
No, on my soul we
Sorry.
were.
It's right here!
Which
You
test?
made 100! Shut up!
I hope you die.
I could not remember it. This was a
Wait, give us like one of the questions to see if we remember it, like from the free response.
Was it the one that we were taking? and
Oh
it
yeah, you
started
guys did
raining?
it last week.
Which one?
On my soul we didn't.
Wow. Well, you know you're dead.
Yeah, it was the one that had the mean difference on the. No. Did I do a mean difference?
That was an effort. That was a
That was a practice FRQ. We still took the test.
Oh, I should be.
I passed it back to y'all. It's in your notebook.
You did?
Did you pass
Where
it
does
back
it
to
say?
us on
That was
Saturday?
too big.
Okay.
It's in your
You
email.
might have.
Hey, Miss Walsh, do you remember where we put that extra packet?
No, I thought it was on that
Freaking
front table, but remember it got all janked up because you accidentally dropped them.
I mean, if you were organized and had a folder.
But it was coming.
Stop copying,
Well, like,
you
that's
guys.
why they
You're
got
all
all
just
dinged
copying.
up.
I can't believe
They
it.
were
I'm
all
down
over
for
the
the copy.
place.
There's a
No,
sheeple.
no, I did it better.
And we found, oh.
Brandon, if you don't
Wait,
hurry up,
you
I'm
go.
gonna steal your M&Ms.
Why is my
It's all
orange pulled?
Yeah,
Let's see information about their shell.
That's
I have like 4 yellows.
It's skewed. It's skewed.
And here's the prayer model.
It's skewed
It's
orange.
not right.
It's skewed orange.
It's skewed
Oh
orange.
no, is this the right one? No, this is the blue version. There you go.
You look at
I
the.
Alright.
have never got
So,
a spray tan in
Ladies
my
and
life.
gents, let's look at it. So, I might have asked this before. Does anybody else actually have a favorite color for M&Ms?
No.
They all taste the same.
I like green.
Brown
They do taste all the same.
I like the brown
However, there's just like a color that I'm partial to. I personally really like green.
I like to sort out the blues
And
and the
blue.
greens.
Don't know why.
Why
I
you
love
not
green
like
and
it
blue.
if color-wise it's blue?
Okay. However, I just want to point out and notice this. So, Hershey, who makes M&Ms, claims, no, is it Mars?
Yeah, Mars.
Mars makes M&Ms. Claims that these are the distributions for M&Ms. 12.5% is brown, 12.5% is red, 12.5% is yellow, 12.5% is green,
This is not true.
25% orange, 25% blue. That is actually what ChatGPT showed as well. Remember when I looked it up earlier this year?
Talking about
Yeah.
ChatGPT.
Oh, it's on the ChatGPT.
Just gotta show the environment a little bit. So,
Oh.
what? So we're gonna do a class sample and we're gonna record the results. So, let's do brown first. Let's add it up. Serena, can you, or Nate, you already have a calculator out. Can you add up however many browns people say? So how many browns do you have?
8.
You had 8. Lana, have you got your browns yet? No.
They could have made this perfect.
Michael, how many browns?
6.
6. Sprig? 6. 6.
4.
4.
5.
And 5.
Guys, we have a few
8.
people. That's crazy.
Lana, do you have your browns yet?
Wait, we didn't
We did.
we didn't count how many M&Ms we have though.
I don't either.
It doesn't matter.
You had 13 just brown? Okay. So how many brown do we have total?
Can I eat my brownies
We have
now?
63 brown. Okay?
No, you can't eat it.
Alright. Let's count up the reds. Jaden.
6.
6 reds. Nate.
7.
7 reds. Sprig, how many reds?
5.
5. Michael.
7.
7. Peter.
What are we counting?
9.
Reds.
9.
9. Lana, how many you got? 5.
10.
10.
5.5.
3, 9.
3 and 9.
3 and 9.
What do you mean a half? You got
Huh?
half of them and then
61 reds, okay. Yellow. Alright. So Nate has his 8. Jaden, how many? 2. That was easy.
5, 6,
Lana?
7, 8, 9,
3.
10.
10 for Sprig.
Dang, she
Eight.
took all of them.
8 for Michael.
What color?
6.
Yeah.
5.
4.
5, 4.
7.
5, 4, 7. You got those?
53.
53. Alright. So you got your 5, Jaden.
4.
4, Lana.
Wait, which color?
6, green now.
5.
3.
3.
I'm sorry, she said
5.
5, 3, 5.
5.
5.
9.
9.
6.
6. 48.
Okay. Orange.
1, 2, 3, 4, 5,
6,
7,
8,
9,
8,
10,
8.
Okay. 8,
6.
6.
6,
11.
11,
12.
12,
6.
Wait.
9.
9,
7.
7,
11.
13.
and 13.
83.
I beat y'all all.
Why are the colors not in order?
Probably because you have bigger
Blue.
portions, Serena.
Oh, I don't want to count all these blues.
Yeah, there's so many. 1, 2, 3, 4, 5, 6, 7, 8,
You guys have all of them.
Wait,
right?
no, let's count 1, 2, 3, 4, 5, 6, 7, 8,
9,
9, 10,
Jaden,
11, 12, 13,
10,
14, 15.
10.
4.
4.
7.
Okay.
9.
9.
6. 6.
15.
Oh.
13.
13.
Okay.
80.
So we know who.
Alright.
Oh my god.
Yes, you now
Now I
make these. Okay, so here's the thing. So notice, Serena, I didn't ask how many total you had because we're not looking at proportions. We're looking at counts this time. How many did you have of each?
Okay.
We will eventually look at proportions, but I need y'all to think about this. One, did all of you have the same number of colors, or even the same proportion of colors?
Nah.
No.
Why not?
Different
Sampling variability.
Sampling variability. Remember, different samples from the same population will yield different results, right? So we're looking at lots of samples here. Now, how many total M&Ms do we have, by the way? I guess we should count that up.
A few.
How many?
A few.
394.
394. Now, if, let me again on this, if we had exactly how many brown M&Ms they claim we should have, how many brown M&Ms should we have?
Whatever, 0.125 times 2.
Oh yeah, 12.5% of 394, right?
So,
So what is 12.5% of 394?
49.25.
49.25. Do we have exactly that?
No.
No. That definitely differs from it, doesn't it?
So that's our expected?
That would be our expected. We're going to get to that in a second. So we would expect to see however many that is. We'll come back to it. But what we need to recognize is we deviated from that, didn't we?
Yeah.
Why did we deviate from that?
Variability.
Maybe sampling variability,
Or it's wrong.
or they're lying to us. I need to remember, like, this has kind of been the whole point of inferential statistics all the way up to here. Either this happened because of pure chance, because of sampling variability, or our null hypothesis, our original belief, is wrong. Now, we've dealt with, what type of data is this, by the way?
Quantitative.
Qualitative? Or categorical?
Is this categorical or quantitative?
Quantitative. You're counting, right?
You are counting. What are you counting, though?
Oh, discrete.
Okay.
Is
What-
it category?
That's not the question. What am I counting?
Oh,
M&M.
and number.
Like the frequency?
The frequency of the color, right?
Yeah.
Is color
Category.
a category or a number?
Category.
Category. I need y'all to remember, so I'm glad I'm asking this. So remember, when we say quantitative, what we're counting is a number, right? So like, or I'm counting some measurement. So like when I say quantitative, how much someone weighs, the response is a quantity. Is the response a quantity or a category? When you look at an M&M, the response is a color, right? That response of a color is a category. So what type of data is this? Categorical. Okay, what type of inferential procedures have we already done this year that dealt with categorical data?
Proportion.
Don't forget, proportions was all about categorical data, wasn't it? But what's the most number of proportions we could look at a time?
2.
2. We did 2 proportion tests, didn't we?
Chi-square test.
In this case, how many categories do we have?
Like 6.
I have 6 categories. I don't want to know about 1 proportion or even 2 proportions. I don't want to know if those proportions are different. I want to know if all of these M&Ms follow what they tell us is true.
I can do all that.
I know, I ain't doing all that either, except there's easy ways to do it. So as a class, write down hypotheses for a significance test. So what would the null hypothesis be here? What do we believe to be true?
Brown equals 12.5, red equals 12.5, yellow equals 12.5, etc.
So you could say, and so there's one way to do this. This is not what I'm going to do, this is not what I would write down, but this is what we could say. We could say the proportion of brown is equal to 0.125. The proportion of red is equal to 0.125, etc. Right? We could say all of that. But what's a way that we could write this out? Because usually in this type of distribution, we just write a sentence. How can I write it out?
I'll be the one.
Could you do probability of brown equals probability of red equals probability of yellow equals 0.25?
You could. Or I could just say this. The true proportions
Or true.
are what, not necessarily true,
Or the same.
are what is claimed
Assume.
of M&M colors are what the company claims.
Is there a less wordy way of saying that?
You can write out all the proportions if you want. That to me was more heinous though. So we could just say, hey, the true proportions of M&M colors are what the company claims.
Oh, you said like 14 words before that. Oh, never mind.
I got receipts, I'm gonna check that later.
Okay, you said like, never mind.
It's not that deep, gang.
So the true proportions of M&M colors are what the company claims. That's what our null hypothesis could be. What's our alternative?
They aren't what they claim.
It's
They're
not
bigger,
different.
smaller,
It's different.
different.
Not what the company claims.
It's not
Okay,
equal.
so, and what we'll say is, at least one proportion is incorrect. Okay? I'm gonna go back and check on that actually while y'all work through the next piece, but I'm pretty sure the best language is usually just at least one proportion is incorrect. Because we're not gonna check to make sure that if every proportion is off, but at least one proportion is incorrect. What's up, Nate?
Right, so would 2 of them be messed up if 1 is messed up?
Well, if one is messed up, at least 2 of them are messed up, but more than 2 of them could be messed up.
Yeah, at least one just means it's one or more.
Take pictures.
Say at least one and then you're set.
What if you do 2?
At least 2 are messed up,
Would you do that?
that's fine.
You good, bro?
Go for it. Alright, so we already talked about this. So let's suppose that M&M's claimed distribution is correct. If they are correct, how many of each color would we expect to get in our sample? So what I need you to do is I need you to find the expected counts for the brown, red, yellow, green, orange, and blue. And then you're going to write down your observed counts, your expected counts, and follow these instructions to fill in the rest of this table.
This is not bio, bro.
This will be, because weirdly enough, it's still the first lesson, I'm introducing the idea, and then we're gonna talk about how to make it easier.
Wait, mine too.
Can you teach us this before Monday?
Calculator.
Yeah, we just gotta say again.
Will you teach us this before Monday?
I'm teaching it to you today if we hurry up.
Are we not
Yes,
supposed to be
Serena.
like you? Like, I hate to be that person, but I'm
This will not be on the test, no, this is the next unit.
I thought we had a BYU today.
Test tomorrow.
Test tomorrow.
It's a 3
My bad. Like I said, I don't want to be that person.
You might have already said it earlier today multiple times.
Okay. Well, at least I was trying to
Trying, I got you.
Yeah, I'll probably
Don't make me feel worse than I already do what you did.
49.25 for like brown, red, yellow,
What?
green. Overall.
Oh,
They're all the same.
oh,
Where we have to do chi-square tests.
it's so.
25.
Serena, you're a chi-square.
Oh,
Wait, that can't
No,
You
be.
better
actually,
punch
so
it
we
being
can
around.
get
What
this
enough?
math.
Because remember
On
there's
literally what you said.
Okay, that can't be.
Expected, so that's 0.125 times 394, then those are all
Yeah, so those are
0.125, like
double.
12%.
So
And then that's
it'd be
25%, so that'll be 0.25
What enough?
times 394. So those are expected, and observed is what we got. And then you just follow the steps.
And we multiply only by 3.
No,
So then there's
I don't want to
Yeah.
eat this. Like, I just.
it's so pretty.
Observed counts.
Wait, so copy these then? I'm going to Insco, I used to get out of
You didn't hear what she said?
Wait, what?
I said my image they're so pretty, like a rainbow. He said, she said, just like you. She just called
We'll
you.
just
gay.
Oh,
So now,
Yes.
how about you focus on your graph?
You still be laughing.
did
I see you laugh. You was laughing.
Serena, so how about we cycle back on that joke about the grade?
How about we get back to learning statistics?
I am. Until Serena decided to be.
I'm gonna eat your eraser, bro.
What?
Whoa.
I feel like that has a
No, it doesn't. He just,
You're
That's pretty
wow.
no, he's just very protective over his eraser. He like freaks out.
But still, it's a little weird.
Did you have a surround down there? We're on the camera.
I'm not.
I can't come to it before. Anyways,
83.
I kicked him out. Does he surround down round up?
Negative 15.
Does he have
Don't round. What are you asking to
No,
round?
like keep it at
How
0.25.
do I calculate?
Well, that would just be
0.125 times 394. So like that percentage times 394. Because expected is just what you're expected to see. So you expect to see 12% of the 394 to be.
Okay, so multiply it by everyone.
Yeah, except for these two,
So
because
this
these
is-
two are expected to be 25%.
Wait.
Negative 1.5625.
That's not.
Thank you.
1.5625.
Jane, can we get Taco Bell?
Of course.
Of course.
That's just big.
Well,
Do
you
they
said
still
what?
have nacho fries
Negative
anymore?
240.
Yes,
Yes,
I do.
they
Oh my
brought back.
god, they're so buzz.
Okay, so it's not big.
2 bucks.
Yep.
I love Taco
I'm not
Bell.
gonna lie, I don't go there anymore.
I had Taco
Well,
Bell
240.
for the first time Friday, and oh my god, it's so
Hey,
good.
have you finished writing your stuff out?
No, but I'm doing it as we speak.
She's working very hard.
Thank you.
Why most homophobic?
Someone sees my potential.
I wanna
You would have expected this.
I saw your potential, I just don't see the work to back it up.
Whoa, Mr. Kenny.
Is you cool? That was so weird for you to say.
Are you okay?
Like, dang, put me on blast like that.
Stat shade.
That is right, because this don't look right.
When did that number get so big?
Hey guys, I want to
Oh,
pause,
no,
I
it's
just
times
want to
the
point this out really quickly. So we should have these numbers, hey guys, right here. We should have these numbers. What is the next column asking us to do?
Square.
Why is it asking us to square it?
Cause it's
If
chi-squared.
you add it up, it'll be 0.
Because notice, if we add this up, just like with standard deviation, this would be 0, okay? So we need to square it, so that's part of, that's the next piece, so keep it going.
It's a lot of work.
That's a lot of work.
Oh, wait, there is a way to plug in the
calculator.
calculator,
Is gonna
isn't
do
it?
all the work for me and I have to write it down?
I thought there's a calculator method.
Maybe.
No, but he always makes us do it by hand one time just to see the pain of it.
Yeah,
This is how he
it.
teaches, bruh. We should know this by now.
I should know this by now.
Whoa, that's crazy.
Mr. Kinney does this thing and then he sticks to it? It's wild.
Mr. King.
8.
Because I'm about to crash out.
I'm finna crash out. I almost cried yesterday because all my papers fell out my binder. I almost cried.
Wait, that's
Like I said,
wrong.
this girlfriend looked at my binder. She
No,
said,
that's not
that's your binder?
Wait, how much should we
He's
round
so
the
judgy on that,
observed minus
bruh.
expected
You should
squared
see my
to?
binder last year.
The like last
3
column.
whatever it naturally
So
shows.
like, what do you mean?
I have like 17 on here, bro.
When I lifted my binder up, all the papers flew everywhere.
I know, it was so
quiet.
sad.
No, it's okay, gang. It's
Like
okay.
literally
It
everyone looked back. I
happens.
was so
It happens,
embarrassed.
gang. It's all good.
No, it just means you're smart.
It just means
That's
you have a
not
lot of
that
work on
Big girl
you.
here. Look
Don't
at
worry.
Jaden and look how messy he
Stay
is.
stacked. Look how big my binder is.
Look how big you are. Don't play.
Oh,
Not bigger than you.
no.
Oh no, it's too late.
Let's focus on learning statistics.
No way. I'm just gonna have.
Oh my god.
I'm gonna bring a scale to class. I need you guys to like scale
We made
that.
He's about to start like censoring it out.
I started kicking some people out.
Bro, we're trying to be monetized.
Bye,
Yeah,
Serena.
you get the green hole.
What if we just bring a scale to class and then have stuff on it? Then we can see who's the real biggie.
Yeah, no,
You should
jokes.
do a
I'll admit it. It's Russell's trust.
Serena, remember the burn from the other day?
The what?
The burn I dished out?
What burn?
No, that would require us to listen when you call.
No, literally.
Oh.
This is
How
not
do you
real
feel,
class.
Jimmy? Because
This is not real
Roasted.
class.
First, I wouldn't think that.
yeah, everyone.
But you know he is, 'cause-
had to get it.
Yeah.
She basically just said that you a B-word. That's basically what she just said.
Alright. If we are working diligently, we should have
I'm
those
almost done.
values filled
I'm
out.
almost done.
Is that a 4?
How'd you do that?
Mr. Kinney, is it a 4?
What?
I focused.
I'm locked in
Is that a 4
too.
or an 8?
Where?
Bottom right.
Here? 8.
Why don't you do it yourself?
I think it was an 8.
I was wondering why I did wrong. I'm like, how come?
Reference
That's an 8?
Yeah.
I thought.
Is there a way to add these all up without plugging in every single number?
No.
I mean, so what I would do is I would just scroll up and highlight the number and then hit enter and bring it down. And again, we'll do this, you know, with a calculator by the end of today, but add up all those numbers.
We should use it on calculator, not for.
No.
Hey, that's not. You're in my area again.
So we added up all the numbers in the last column. Is our chi-square test statistic.
Definitely.
Wait, you didn't get a negative number?
I don't think anyone.
Why would it be negative? It says
Yeah,
add up all
square
the
it.
numbers
How
in
would
line.
We
you-
square it.
Yeah.
I got like a billion negatives.
Serena, well, when you squared it, your calculator automatically made it make it negative.
Oh.
Wait.
Did you
Oh,
square
they
you have
it?
to, like,
put it in parentheses.
Yeah.
Yeah, did you put your negatives out of parentheses?
Oh.
Wait, I got like 10.184.
I got 10.78.
10.985, said about right.
I got 10.7828.
You didn't do it right.
I'm doing mine. I don't like Mr.
It's your
Penny's.
7M.
9848. Is that what you said?
I'm sorry.
What'd you
it's
get?
cute.
Like 10.1847.
And I got 10.7828.
We got 10.9848.
Are these the numbers you got up here?
Yeah.
Oh, maybe because I rounded by 4 digits.
So his is
I
more
rounded.
I
accurate.
don't want to do that math, so I'll just copy it.
I'm so sad.
Okay.
Mr. Can you be a huge favor?
I know.
No.
Alright.
What?
Can you explain to me
Are we
how you got the expected counts? Because I did it in my calculator. So
It's
you
a
can help me, but-
0.125 times 394. That's just expected.
125. So then you'll multiply them
Because
by
that's
394.
because that's 12% of 394, and you expect to see that for the brown.
Okay, so I got the numbers. I actually pressed divide by accident.
Okay.
Thank y'all.
Alright, so what value would we get for chi-squared if our sample was very close to what is expected? If what was expected, or what we got was close to what was expected, what should our chi-square statistic be?
0,
It should be 0, right? Why?
because they're exactly as expected.
So when we subtract observed and expected, we get 0 or really close to 0. And then when we square it, it still stays close to 0. And then when we divide by what was expected, we stay close to what?
0.
So if our sample was very close to what is expected, chi-squared, that's not right, hold on. Yeah, that's right, okay.
That's how you write it?
Yeah,
Bro, that looks like a chromosome.
So you just write a
or
chromosome?
is it?
Why is it literally a
No,
chromosome?
that's it. I always write it backwards.
You just write a chromosome, okay.
Chi.
Wait, you're
Wait, that's
putting
just
it
how
up
some
here.
people write X's.
That's how I write my X's.
Yeah, that's how
Well,
Jay
then-
writes his X's.
Well, the way you
Then don't
write
write
X's
like
is
that.
wrong. Alright, so chi-squared is what we would expect to be 0, right? If observed equals expected, the observed minus expected equals 0, right? So if they're very close, even if they're a little bit away, I do want y'all to notice that, even if they're a little bit away, when we divide by what is expected, it's going to get closer to 0, right? So, yeah, good talk. What value would we get for chi-squared if our sample was very far away from what is expected?
Higher than
Critical
the
value.
chi-square critical value.
So, we would get would be large.
Large like Peter.
Serena?
Like,
You know what, I was being nice and respectful.
You were literally about to say it. I saw you.
Serena, stop. Peter, stop. I'm done with it today.
No, I
I'm done with it today.
But me and Jay are a problem.
Chi-squared would be large. They're not even in the same group. Okay, so if our sample is far away from what is expected, chi-squared would be large, period. I will point this out. What is the smallest value chi-squared could be?
0. No?
Can it be negative?
No.
Well, no.
I mean,
Because
so
of the-
What is it?
If it's negative,
We're squaring it, right? Like,
Do it.
if we're squaring, you cannot get a negative, right? So we square it, and then we divide by a positive number. So the smallest value for chi-squared is 0, but could chi-squared be pretty large?
yes.
Very much so. Any guesses then what the shape of a chi-square distribution might be?
Like this.
I mean, it's
Skewed right.
You think it's gonna be skewed right?
Lineal.
So the
Just-
minimum
Are you
is
talking
what
about
again?
any,
The minimum
chi-square or
is
just this one?
0. Huh?
Are you talking about any chi-square, like, distribution or just this one?
Just in general, chi-square shape. Peter, what is that?
I don't know.
We got it on the mock.
It was also on the formula sheet, or on the table. Notice there's a large chunk here, and then it starts at 0, then it is skewed to the right. Make sense?
Oh,
We'll
that
do more of this in a
thing.
second, okay? Huh?
Oh, that thing.
Yeah, that thing.
Yeah.
Okay? So here's what I now need us to do. Nope, it's not even up there. Hold on.
Oh, that means something.
Table.
No.
No, I thought we were just gonna ignore that, bro.
Okay.
Make me
So-
sad.
What I'm going to do is I'm going to go to the candy applet. I'm going to enter the observed counts. And we're going to simulate taking 1,000 samples. And I just need you to, let's see. What was the applet again? Applet.com
Candy. How do you have such short names? Who else uses it?
/candy. Applet. Alright. What?
Can you
it
do
helps
the
And
if
if
you
it's
spell
all linked to like one person,
candy,
you
right?
can just like.
I know, but like the URL, it's like.
Alright. So
They had no better use for candy.
we have those percentages, and we need to enter the observed counts. Alright, so how many brown did we have?
63,
Thank you. Red,
61,
yellow,
53,
53, green,
48,
orange,
83.
and blue, 56. Okay. Let's see. 1,000 samples.
Dun, dun, dun.
Alright, so there's the distribution. Notice what shape is that? It is skewed to the right. Alright, so man, we have one huge chi-squared. So what was our chi-squared?
10.18.
10.18. So we want, calculate the
No, 'cause
number
I rounded
of
it.
percent
Huh?
of dots that are greater than 10.18.
I can't read that.
What?
Oh, you can do it, okay.
Yeah,
I thought you meant like us for
for
to
us.
do it, oh my god.
Okay. There we go. So how many dots are there?
A few.
It's like 68.
68 dots or 6.8%.
That's not very
That's
likely.
above 5% though.
That is above, so is it likely? No. Is it so unlikely we believe that it's not actually that percent?
No.
No.
So you don't have enough evidence.
We do not, I love that language, right? We do not have enough evidence. So please do a quick sketch of this graph, right? Put that sketch right there for our sampling distribution
Oh.
or our
Get
simulation.
back.
And just do a density curve, really. I'm gonna draw all those points, obviously, it's 1,000 of them. Or if you're too
Now
cool
these
to
roads.
write notes, like Jaden, don't write it down.
You're supposed to do like.
So,
Well,
say it
I mean,
one
they're
more time.
both edible, it's fine.
You chose greater than.
Great question. So, anyone know why I chose greater than?
Because it's above the
So one,
It's gonna stick out,
remember,
so-
it told us on the sheet to do
Oh,
greater
It's
than.
like,
more
it's like
extreme.
things on TikTok.
So it's that or more extreme, but also it's what? It's chi-squared. So do I ever want to go left if it's chi-squared? No, we're squaring it, right? So even stuff that would be on the far end on the left actually ends up on the right once we square it. So it's at that value or more extreme. Because it's at or more extreme, it has to be to the right. You with me, Braden?
So yes, value?
It is a p-value, yeah. In this case, greater than 10.18, isn't that the probability at or more extreme than? We get into a rough spot.
Sad.
I blame Serena.
I like it.
Oh, yours didn't go all over the place like somebody's. Oh no.
Oh, well,
wow.
you caused it to, so.
I like what you just did.
First tweaking out.
I know, I'll quit trying
Are
to
you
help on that. Alright. Whoa, okay.
He's
Okay,
going through it. Yeah, I know.
so hopefully you have that graph. Highlight your p-value there. Okay, so, oh yeah, I should go back to here. How likely is it to get the chi-squared value we got in class today?
0.068.
So, I'm gonna erase all this.
It's like,
Where do you get that from?
it was from 5
So how likely is it? So the probability, hey, what should I put inside my probability notation, do you think?
Chi.
A chi-squared. So probability of chi-squared greater than or equal to 10.18.
Where's,
Given,
oh, down here.
given, wait, do you need to do a given?
Well,
Well, you don't need it, you don't need it.
we can say given the null is true.
You just
Yeah,
like-
why are you always so
Nah,
extra?
just because it's chi-squared, right?
Okay.
No, yeah, we don't need all that for
Okay.
chi-squared. So the probability that chi-squared is greater than or equal to 10.18 is equal to what? 0.068. So what is that value again that we just calculated using the simulation?
Like a p-value.
What you looking at over there, son? Put it
Oh,
away.
that's the laugh, Fred.
Okay, what is that value?
P-value.
That's a p-value.
Like,
Alright.
you talking about me?
Huh? No, I was talking about him.
So-
Wow. It was an interesting laugh, I'm just saying.
So the p-value, I don't remember who said it, but what we need to recognize is that p-value would mean that we have what kind of evidence?
No convincing evidence.
Not sufficient evidence, not convincing evidence, not statistically significant evidence for the alternative, right? We would fail to reject the null. Is that unlikely? Yes. Is it so unlikely that it's unbelievable?
No.
Now, I will say this. There is one case where we would have statistically significant
If the alpha
evidence.
level
If
was
you had
It's
the-
like
1.
0.1.
So remember, if you change your alpha level to 0.1, we would reject our null hypothesis. What might be a reason that we would want an alpha or a significance level of 0.1 in this case?
Because
Or-
it's-
Type 2.
Because we're worried about a type 2
type 2
error.
error.
right? Remember, if we increase alpha, the probability of a type 1 error, the probability of a type 2 error goes
Down.
down, right?
What would
So-
the type 2 error be in this case?
So type 2 is when you fail to reject when you should have rejected. So when we believe that the distribution is correct when it's not actually correct. Now, is a type 1 or type 2 error in this case deadly to anybody?
Yes.
Is it consequential?
It's just
Yes.
M&M's.
Yeah, it
Now,
killed my grandma.
I will say this,
Which grandma? Last I checked,
Oh,
our
yeah.
grandma's still alive.
this might sound goofy, but like, if the case is that we like redo, if I'm working in a factory that is creating these M&Ms, then there may be one that I'm more concerned with than another. So I don't think I told this story yet, but T distributions were actually discovered because of a statistician working in a brewing company.
Oh, I
where-
watched a video on that this morning.
Did you? I need to go back and look up his name. But legit, he was,
I forgot.
he was, he was using a Z distribution to determine, for a significance test, and realized that they were stopping the production too often because they were getting data that said that, oh, the alcohol content or whatever was not at the right rate, but they're dealing with a mean alcohol content. Well, we now know with means, if we don't know the population standard deviation, that Z critical value doesn't work well. And so he explored the T distribution and discovered that to account for it. So all that to say, if we work in a factory and we're really worried about stopping production too often because we think things are off, then yes,
How do
we
you make-
do have.
How do you get rich after discovering some math thing like that?
The Millennium Problem?
You go work for a brewing companies because people like their alcohol.
Right, a text
Like point blank period.
Like-
No, but like, what if you like come up with the T, like he came up with the T distribution? Did he get like rich off of that, or?
Oh, no, that's a good question. No idea.
The Millennium
All right.
I don't think you can patent a like.
Serena, one of those $1 million math problems.
Bruh.
$1 million
Like the Millennium Problems, but like the Rubin hypothesis and
I don't know what you're talking about. Okay.
Yeah, you do. Good job.
Alright, so let's look at the quick notes
No, it
here
was Eminem.
before we actually do this in the calculator instead of by hand. Alright, so does anyone know the test name that we just did?
Chi-square.
It is chi-squared. Chi-squared
It's like 10 for significance.
goodness
Goodness of it.
of fit.
Bruh. Oh my, it's some dang goth movement,
Okay.
bruh.
So the chi-squared goodness of fit. Essentially what we're saying is how well does our data fit the expected, right? So how well
Observed data.
does the observed data fit what is expected?
Right.
Okay? So in this case, what's our null hypothesis going to be?
Like it's
That doesn't change from the blah blah blah.
The distribution. Make sure we talk about that distribution in
Oh, yeah, that's.
Context.
context. Okay, so the distribution is what is, or matches what is claimed. Oh, no, we won't say it matches, is what is claimed.
Right.
Okay? So the distribution is what is claimed. And so what would our alternative be?
It is not.
it's not.
It is not. It's more than or is less than. Less
Or
than.
not equal to.
Okay? So the distribution. What? What? What do you mean?
4.9%.
Okay, you changed it to 10,000.
Huh?
We'll look at it more in a second. And also, it wasn't wrong, we just did a different,
Sample
I think we
size.
should, you should have done a bigger sample size.
well, that's not a bigger sample size,
Or
there's
bigger
just more
simulation.
samples.
Oh.
Whatever. We'll look at it again in a second. Okay, so the distribution in context is not what has been claimed. And by the way, when we talk about that context, it is important to remember this is what type of variable.
By
Right, remember the whole idea is that it's a categorical variable. So the context needs to talk about the categorical variable. So the distribution of the M&M colors is what is claimed, or what is what has been claimed. Versus the alternative, the distribution is not what has been claimed.
So no hypothesis is categorical?
No, this is all about categorical data.
Oh, the whole thing. Okay.
Okay. Learning target number 2. How do we calculate a chi-squared value?
O minus E squared.
So what does O stand
Oh,
for?
wait, you have to do the sum.
Observed minus expected squared
Is this on our
Over
formula
expected.
sheet?
divided by expected,
EXP?
Sum, you have the sum.
and then the sum. Right, so it's the sum of the observed minus the expected squared divided by expected. What did you say about that? That was a second ago?
Okay, ready? You gotta get hyped.
I'm so hyped.
Formula sheet.
It's on the formula sheet? Oh my gosh!
Formula sheet.
Wow.
That is mind-boggling.
Bro.
Nuts!
Every single time. Every single time. Literally every single
That's
time.
something.
I feel like it should be distinct.
So,
I think he's playing it.
Yeah. It's like whenever, like you say 9/11 and the crack is loud.
9/11 was
The
bad.
crowd-
this is not the same at all.
I know exactly what senior time.
9/11.
Nine.
Huh?
You got
11.
you got some paper.
So notice right here,
Bro,
hey guys, right here, this is
It's a
on
family guy
the
episode.
formula sheet, right under sampling distributions and inferential statistics.
Wait, so we're like done with formula sheet.
We have learned everything on the formula sheet. We're not completely done though. Alright,
Okay.
We'll never
so, right here, last couple of things. So our chi-squared distribution has what shape?
I mean,
It is skewed right, and then we're gonna look at chi-squared or more extreme. Now, I need you to look at your chi-square table. I need you to look at the chi-square table because we're missing something.
I'm sorry.
That's the z-score. I need you to
I
look at the chi-square
I
table.
threw these out yesterday, bro. I thought we didn't need them.
3 now.
Oh, wait, look at that.
You didn't need them while we'd be there.
Within this.
Mr. Kenny, can I please have a chi-squared
I'll just
formula?
pull it up.
Wait, Serena, I probably have another copy.
Right here.
I had like 5 of them and I threw them all on my
Okay,
bed.
guys, look up here, which I'm never going to use a chi-square table, but does anyone see anything on this table that I'm missing?
No,
Degrees of
because you have all the letters.
Degrees of freedom.
No. Oh, it's
I know
just,
you did,
it's
but I
just
want
n
us to
minus
look
1.
This is not.
Close.
Or it's like the group of
N minus
at.
two.
Number of categories.
It's gonna sound, it's the number of categories, it's not the sample size
That's what
anymore.
it is.
Hear me again on this,
Six.
it's not the sample size
So
anymore.
minus.
That's what I got
The
wrong on my bio
degrees
test.
Of freedom is k minus 1, where k is the number of categories.
Ah.
So the degrees of freedom, what was the degrees of freedom in the M&M case? The degrees of freedom would be 5. It was 6 categories, right? 6 colors, and so the degrees of freedom is just 5.
What?
Great question. I got no answer for that one. Actually, my guess is because we use C for confidence level. Like a C% for confidence level, that's my guess. Okay, but we use K there. Alright. We're gonna come back to this after we do the next part, after we finish this as extra practice. But I wanna look at the next lesson, 12.2 really quickly. Okay? So now, guess what we're gonna learn how to do?
Hopefully boss food.
Use the formula
Calculator.
sheet. No, use the calculator. Thank
That's
you.
literally what they
You
said.
press menu, do so.
Okay.
Now, what's that button that we press that does that does all the cool crap?
When we do like the matrix stuff,
That is not goodness of fit.
Because we're not
that's
here.
independence, right?
We'll look at that.
Are we on
Buzzwords.
When do I do the makeup series?
Too bad, so you better be here tomorrow. Alright.
Is there?
Now.
Anyone want to take a shot in the dark where we're going to enter this data?
Menu.
Menu.
No, that's a button. Where, what?
Stat test.
Okay, so let's go to,
It says it right there.
okay, so
I'm sick of freaking this spreadsheet.
I'm gonna add a
Show
calculator
me the
page.
preview.
I'm gonna go to menu,
Oh, put it down.
stat test, and notice chi-squared goodness of fit, right?
Wait.
Wait.
So, calculator page,
What about the
notice statistics.
There's
Is it stat test? Yes. It's okay.
Well, that's what we're about to look at. So when I go to chi-squared goodness of fit, what is it asking for?
Observed, expected, diagram.
Observed what?
list.
List, expected, list. So what do I need to go to first, actually?
Listen,
List
spreadsheet.
I need to go to list and spreadsheets.
I have way more than that.
Did you do, what?
You had 3. I have 4 options.
Let me see.
Unless I'm wording the right thing.
That's because you're in the list and spreadsheets. Okay,
No.
add a list and spreadsheets. I would do a new list and spreadsheet. So I'm gonna put my observed M&Ms, and I'm gonna put my expected M&Ms.
No, I was doing the Sunday, Monday stuff, so.
Oh, no, the M&Ms one. Okay, so what was my brown again?
Bro, we've told you this like 4 times.
63.
And then whatever was next,
61,
then
53,
53.
48, 83, 86.
Thank
This
you.
is like bingo.
Y'all have it written down.
Bingo!
Was it 48.25 for the
Yeah.
expected?
No, 49, which is
49.25?
What?
Let's play blocks of bingo tonight.
Wait, actually? No, I have to study for this test.
I don't.
98.5.
Yes. And I'm also gonna watch Attack on Titan
Okay.
again.
Bruh.
So, make sure you have your data in list and spreadsheets, okay?
Now menu.
And I will say this, I'm gonna show you what it looks like in the calculator page. I actually do recommend you running this in a list and spreadsheets page, and I'll show you why. So menu, statistics, and where next?
Stat tests.
Do you have your data all in?
EO.
You need your observed and expected.
Wait, what's my calculator almost dead?
What's our degree freedom? How many colors are there?
A million.
Okay, so statistics, then, where are we going?
Do we shade the p-value?
Stat test, I don't, it just makes it hard to see everything.
Okay.
And then goodness of fit, right?
Why is our p-value 0.049?
And so I'm
I got
gonna put
0.05.
observed. and
Yours
I'm
isn't
gonna
rounded
put
because mine's 0.04909.
expected, and my degrees of
No.
freedom is
All of a sudden,
5.
my stuff don't want to work.
Wait, what am I doing?
Oh, do we draw
I would not draw, I would just do that.
Peter,
it? What
I
happens
miss
if you
you.
draw it?
I miss
I'll
you.
show you.
Okay.
Where is this?
Mr. Kenny.
Notice it draws the,
Every second with
that
my
there,
music,
but the
my
issue with
beats,
this
my guns.
is notice I can't see anything over here.
Oh, yeah, it's pretty
That's why I don't do that, Brayden.
Does that say cool down?
No,
Fish.
it's not working. You are still clicked inside of here. You gotta get out of that. Now you can do it. Just click on the arrow to the right.
Mr. King, what's a poison PDF?
Don't worry about it.
What is it?
Wait, there's this
Fish!
Oh,
Fish!
so we have to do
Steve
this
the fish.
Stop.
There's not to do this.
Never
There's also
saw Steve.
I'd have to go back and study it. Don't worry about it. We don't study it in this class.
Where is this? Where is it?
Okay, so we should have
Oh, I found it.
all that data in.
I think you forgot
Three,
something.
or I put 5 in.
I think you forgot
Hey,
something.
Jane.
I put it in there.
Six
All right.
something degrees of freedom.
I'm gonna just pray that we
Yeah,
have.
You need to put what? And I don't think so, but we'll find out. All right, so.
What is that?
Why is this? Okay,
What the freak? How'd you make it so long?
it just did that.
No, I was just watching for you.
All right, so notice there's chi-squared, there's my chi-squared value, there's my p-value, and that's probably just down to, no, that should be the p-value that everyone got.
Yes,
I
it
got
is.
I got 0.04909.
We did it wrong.
I did.
That
I
means you
got
typed a number in wrong somewhere.
34.99.
What if
I
you
don't
typed the number in wrong?
I did.
know what I did.
I think you typed a number in wrong.
No, I got the same thing.
So,
You're strong.
When most people get the same number, sounds like you wrong. Alright,
That's not true,
degrees
that's
of
not true.
freedom.
Miss Therapy class taught us that.
Now-
Yeah, exactly.
So,
Wait, I actually did type it
hey,
in.
really quickly, I want y'all to hear me on something, okay? Does anyone have an idea what these numbers right here under the comp list is?
It's like
The
expected square.
Yeah,
These are the components of the chi-squared. So that's the observed minus expected squared
is that why
divided
it says
by
comp?
expected. Yeah, components. So notice that's each of these values. This will matter for a later thing because one of the things that the AP exam will ask is, or will sometimes ask is, hey, which of these was the most unusual? How can I tell which of the categories was the most different from what we expected?
Because
The one that's
difference.
like largest.
Wait,
The largest
we
one.
had a question
Yeah.
on AP bio about like which contributed the most. Was that
Correct.
relevant?
Yeah. Because notice, like right here, how far apart are these?
Pretty far. We're not too far.
14 point something or 13 point something,
Sure.
whereas these are 15.5. So which one is contributing the most to chi-squared?
That one.
The other one?
Not this one, it's the other one.
Because divided by the expected.
Because remember how we divided by the expected? So notice how this contributed more to the chi-squared value than this did. So one of the things that they do ask about sometimes on the AP exam is which one contributed the most to the chi-squared. And so yeah, even though that earlier one wasn't as different, because we divided by a smaller expected value, it contributed more to the chi-squared. Okay? So remember how on this,
So that's how you get that one question from the AP bio MCQ.
Which one?
Which
hey, pause,
contributed the
and
most?
let's look at this
The
real
lizard
quickly.
one?
Hey,
Oh, never mind.
okay, so remember how we got chi-squared by adding all these up? That's why I needed us to do this earlier, right? So which of these contributed the most to chi-squared? That's the question.
What are y'all doing?
And so,
It's down
did you just
there.
break that?
No, I was taking out the.
No, one thing about Serena, she takes things apart and puts it right back together. She's
All
trying.
right, so we need to recognize that what they're gonna ask sometimes is, what was the largest contributing factor, right? And so that's why you wanna look at that components list. If you look at that list in the calculator page, you can't actually see it. You can only see the components list in a listed spreadsheet page. Don't know why they did it like that, but they did. Alright, so here's what I want y'all to do. I want y'all to work through the choose, check, calculate, conclude. Show what work you think would need to go there, and then we'll talk about it. One thing I need y'all to pay attention to, under the check, what conditions do we need to check? It's gotta be a random
Large.
sample, okay? We need independent observation, so we need to satisfy the
10%.
10% condition. What's the last one?
Normal.
Large counts condition, because it's proportional.
Oh, the number of expected is 0?
I need y'all to think about this for a second. Do we still want a normal distribution?
No, we want a skewed one.
We want a skewed one, right? So we still need to satisfy large counts, but the large counts is not the same that it's always been.
Oh, so you want it smaller than?
Is it 5?
You don't want it smaller than 5.
What's a 3?
No bigger or greater than 5?
It is all expected are greater than 5.
Sorry.
So you still want all expected greater than 5, but I'm just trying to, all expected counts, I should say. I want us to understand, do not talk about normality with chi-squared. Let me say that one more time. Do not talk about normality with chi-squared. Because chi-squared is skewed right. It's the only one that we have to worry about all year that is not approximately normal. But chi-squared is skewed right. Alright, I
What
need
percent of the
you
exam
to
is this?
go through your choose, check, calculate, conclude, write this stuff out to help you practice it. Michael, you're here, you might as well, try writing it out.
Even white is someplace over.
No, I wasn't. Who's
No.
like
He did that in AP thing
Block
too.
that.
Liar?
What
How do you
percent of the
know that?
exam is chi-square?
No.
5 to 7%, I believe.
I'm not a good liar.
That's why I left
Yeah,
it
we
for
know.
2 days at the very end before we start review. But it still was 1 or 2 questions, I think, on the multiple choice, right?
Yeah.
And it's
No, it's just
not,
one question.
yeah, it's not infrequent on the free response. Let me say that one more time. It's not infrequent on the free response. If it's not a lot on multiple choice, it will be a question on the free response. If there's more questions on multiple choice, it probably won't be on the free
Are
response.
you
What would the
gonna
parameter
get,
be?
the stuff, like the grades you have in by tomorrow?
I'll get them in tonight.
Okay.
Yeah.
And
But
if I don't have an A tomorrow, can I come in here during your free block and
Do something.
talk about stuff I know?
I might do the same, low key, low key.
Hey,
Alright,
What's the process?
but I need you doing your choose, check, calculate, conclude.
Dang.
Serena, yeah,
Okay,
yeah.
I have not even read it.
Huh?
you wanna
No,
know why?
it was the final exam, but it wasn't the final.
You were asking
wanna know why
about
I
parameter.
made
I'm gonna
formulas?
check in a second, but my guess is
So macros
just
had a
the
formula?
true proportion of M&M colors,
Memorizing.
right?
Got
That's a
68.
parameter.
How?
So the distribution of the true.
Huh?
I didn't even got an
Why?
employment.
Hey, we just welcome to enjoy the next 24 hours.
I just
Have a
listen
good day.
focus on this class.
Enjoy your next 24 hours.
What
you mean by that?
And just have a good day. Bye bye.
That's good. Okay, so that's what I was wondering. So so do we have a parameter like we have in the past? Do we have a P or a mu?
No.
So parameter this time, just don't do it. Do we have a statistic like before, like P
No.
hat
No.
or X bar?
So we don't
No.
do evidence for,
Correct.
okay.
And that's why, like, I don't do the statistic or the evidence there anyways, because it's not always applicable. I only define a parameter if there is a parameter. With chi-squared, you don't have a parameter to define. Okay? So do your choose, your check, your calculate, and your
This is
conclude.
name from South.
Wait, so you don't really.
How about that stats though?
Wow, what's done?
So it doesn't really matter when you like which inequality you do. It's like this is not true.
Yeah, you don't do an inequality. You would just say,
It's not true.
so what do you say? The companies, well, you need more context, so you need the categorical variable in there. The company's claim about the
Proportion of
proportion of M&M colors is true or is correct, the claim is incorrect or is false.
I'm just reading.
Oh, I have one pencil left.
That's cool golf.
It's like a blind leading the blind.
How bad are your visions? I bet I'm the blindest.
This is okay.
So no parameter,
No
no statistic, no
use that one from now
evidence for alternative. But
Large
hypothesis
contribution.
is,
Would the large counts be 0.125 times?
I have,
So the
Oh, you mean
large
grade ones?
counts, you need all the expected counts, but this is a question that I asked at a mock reading one time. If you can identify what the smallest expected count is and show that that is satisfied,
So
then you're good.
expected count, so that's 12.5%, right? Okay.
Well, and there's also the 25%, but you don't have to check that one. If you say the smallest expected count is this, which is greater than 5.
I'm in pencil poverty, bro.
Ask for a pencil.
What do you
Oh,
have
when I ask
that?
for a pencil though, you be like Bill, like or Scott Black, right?
Sanaya.
Wait,
So I don't have
I'm
one.
not gonna acknowledge.
So you make
stupid
me
statements
find
or
pencils off the
questions.
floor, but you just gave Serena a pencil.
I literally went and picked one up for you the other day, and you're like, "Oh, I've already found one." I was like, "All right, whatever."
That's not even true.
you peed.
Yes,
Yeah,
it,
but I don't dispute it. That's
someone else gave
why
you
did I
one
keep on
first.
misspelling
Sanaya.
correct?
I don't. I remember the pencil, but
Sanaya.
Okay, so I.
On pencil?
All right. So what's our procedure?
y'all didn't see that?
What? I'm not
Sorry,
sure.
Kai,
He was like,
I said you want a pencil.
What's our significance level?
0.05.
0.05. We don't have to worry about statistic or evidence or parameter. Our hypotheses, null.
The true proportion of M&M colors are what the company claims.
Okay, so you can say it that way. You can say something like the distribution
Could we just put like the great word now?
of M&M colors
Okay, you don't make no sense.
is correct or is
You
true,
got patience.
or the claimed
Mostly.
distribution, I should say,
The host of patience with the action.
is true. And the alternative is the claimed distribution is incorrect.
Or what?
Ask for patience at the THB, like the action.
All right. So, did we have a random sample?
Yeah.
Basically.
Yeah, essentially. Random
We assume.
sample. How many M&Ms did we have?
394.
Is 394 less than 10% of all M&Ms?
Oh wait, I thought
Probably.
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 Peter eats more than that, so
Okay. Large counts. Now, hear me on this. Serena was asking a good question. How many categories did we have?
Six.
6. So how many expected counts do we need to check?
6.
6, because it is all expected counts. However,
But a lot of
I-
them are the
Sounds
same.
huh?
What if like four of them are the same? Do you just have to?
Well, remember what I was telling you earlier, and I asked at reading, is if I make it clear that I have checked it the smallest expected counts, is that fine? The answer is yes.
How do you make that clear?
You make a note.
Smallest
Expected count,
expected counts
49.5? No, 0.25?
counts is, and I would show the work of 394 times 0.125 equals, was it 49.25? So as long as you literally just say the smallest expected counts is this, and this will matter a lot for when you do two-way later.
So we can do that too.
Huh?
We can do it on 2A too. We don't have
Yes.
to do a lot.
What?
You couldn't have told us that before we took all the tests, and I spent like 5 minutes writing all that.
You mean in biology?
No, in here, like for the.
What?
Oh, no, you have to do it in here for, or you
For the
have for
proportion,
proportions,
like,
you have to do it for all of them, yeah. I will say, and I did mention it then, you probably could get away with it then, but I would just be safe on that.
Okay.
But this, we have a lot more things going on. So, all right, there's mine.
And 3 holes.
Nope, frozen, so that doesn't. All right, so general formula. What's our general formula?
Chi-square equals observed minus expected.
The sum.
So,
The sum
My bad.
of
Dang.
observed minus expected
squared.
squared divided by
Expected.
expected. You know what
We're
you
talking
need
again.
to do for this test,
Right.
if you have to do it as a free response?
Write that.
You need to plug in a few values. You don't have to do all of them.
Double, you usually do double that.
What if you just put
So-
you write the components out?
What was it 63?
Yeah.
Yeah, for brown.
So
Oh my gosh, you
63
did it!
0.5 squared divided by what?
2, or no.
49.25.
49.25 plus plus, what was the last one?
86.
Minus 98.5.
98.75.
No.
Oh, that's what I did wrong earlier.
Right.
Okay. Notice I have plugged those values in. Remember how I showed you that component list? I would show a couple of those values. So chi-squared equals, I don't remember what the first one was, 3 point something?
Yeah, something
Yeah.
like
If you went through this up, Peter, he'd like eat it.
2 point something?
What'd you
that. Something like
Say it
that.
louder.
You ready?
Okay.
Over your mouth.
And so what does that chi-squared value equal?
10.9848.
10.9848. I'm going to draw my picture. Woo.
Wait, so you don't need a specific formula, right?
I mean, there's no real general like
Yeah.
there's been in the past. It is this specific.
Oh, wow.
Ah, right. All right, we'll finish this up tomorrow. So what was our p-value?
He always pushes past the bell, and I'm always late.
0.051683.
Okay.
Nerd.
Oh no, he can read from a calculator. Oh, the villain.